Simulation of COSEEN, the collective decision-making model. Hi folks. The Common Sense Engine, or COSEEN, attempts to optimize the political and economic system. For more details, please watch the featured video of the channel. In this video, I will walk you through an Excel-based simulation of the COSEEN collective decision-making model, or COSEEN. This time we will translate the theses into algorithms and test whether the numerical results correspond to our expectations. Let me start with some definitions and rules. Ideas that fuel COSEEN include everything you may imagine. You can share ideas and vote about ideas without virtually any limitations anonymously. You might also join communities as you wish. Your activities create a personal code of conduct for you, and you get compensation for your work. Two types of ideas support structured and meaningful debates, resulting in constructive actions. You can point out fallacies and biases or create projects. We will discuss those in a separate video. In this simulation, we will learn about the voting process and the concept of equal average voting power, and we will connect people to communities, communities to ideas, and generate codes of conduct for each person, talk about endorsements, and discover a method to calculate compensation in a way that leads to maximal collective intelligence. The yellow cells contain input information that can be set arbitrarily within defined ranges. One could enter these manually, but for this demonstration, I have used the random function in Excel so that we can check out many different scenarios without entering tons of new data every time. The light blue cells contain calculated fields. In this first simulation, I cast votes for 10 different ideas. I may pick a number between -100%, strongly disagree, and +100%, strongly agree. Equal average voting power means that the average of the absolute values of my votes should be 100% after each ballot. As you can see from both the table and the chart, after my first ballot, my first vote is always worth +100% or -100%, regardless of what I choose. However, each of my past votes changes whenever I cast a new ballot. Please note that these changes become smoother as I cast more votes, and the order of the ideas does not change over time. Next, I populated ballots for 10 people on 10 ideas. Inclination to vote in light green reflects the experience that some people are more likely to vote than others. In the bottom table, I have equalized the average voting power just like I did in the first simulation. Now we can sum up the votes for each post and rank them accordingly. The more people support, the idea will be ranked higher. Divisive posts with both positive and negative assessments will stay near zero. This section maps people to communities. Again, we have a factor called inclination to join because some people are more willing to join new communities than others. The bottom table ensures that all people's total portfolio is 100%. If you join many communities, you will have less voice in their decision-making than members of fewer groups. Now that we have a mapping of people to ideas and people to communities, we can connect the dots and check out an idea's popularity in a specific community. Using that and the membership information, I have generated a table that shows the assessment of ideas by the communities of each person. It is important to note that these numbers include the votes of all members of the same communities. We have created a personal lawbook sorted by the importance of each rule. As you can see from the chart, some ideas are popular among many communities. Others are unpopular or neutral. And some ideas are popular in some communities but unpopular in others. A special kind of voting is when you endorse someone. You cannot do that to yourself. An endorsement is always positive, i.e., the numbers here are between 0% and 100%, and the number of people you endorse may depend on how friendly you are and how much you can express it. An endorsement also counts as an idea. You can explain why you have endorsed someone, and others can react. Endorsements are a great way to express appreciation for precious things that do not have a monetary value, being a good parent or friend, keeping your environment clean, making people around you smile, and so on. In the final section of this simulation, I calculated the performance and compensation for the activity of 10 people in a month. The more ideas you post, the more reactions your posts receive, the more popular they are, the more votes you cast, and the more endorsements you give and receive are all factors in your performance review. I have made up random numbers for these activities, except for the endorsements, because that data comes directly from the table above. It is hard to predict how many ideas people have and how many votes people cast daily. For now, I have calculated with dozens of proposals and hundreds of votes. You can see that I applied different weights because, for example, posting an idea typically takes more effort than casting a vote. These percentages are arbitrary, and either the same decision-making process could determine these, or we could use the golden ratio of decision-making if such a thing exists. The second section calculates the performance of each person compared to the others. In the income row, you can see that assuming an average income of $10,000, how do we distribute the $100,000 among 10 people? The importance of performance is a crucial parameter. If it is lower than 100%, the difference is a guaranteed basic income for everyone, regardless of their performance. In COSEEN, the votes of the members of your communities, including yourself, determine this parameter. I used normal distribution because that reflects the performance of an arbitrary group of people better than the random numbers. Let's look at some extreme scenarios to illustrate the outcome. If person number 7 is way better in everything than anyone else, and the importance of performance is 100%, the reward will be approximately 2.5 times the average income or 3.5 times the median income. However, person number 7 will get only a few percent more than the second best performer. This salary cap, along with the inheritance rules, prevents fraud and extreme wealth gap, but it does not stop person number 7 from earning much more money by running projects. We discuss inheritance rules and projects in other videos. If person number 7 does nothing, and the importance of performance is 100%, he or she will still get $180, which is about 2% of the average income. If the significance of performance is 0%, everyone gets $10,000. The next chapter illustrates that we can do the same calculation for any arbitrary period. Cash flow is continuous and recalculated whenever someone does something in the system. In this example, we follow 10 persons for 10 days and project their performance for day 11. In the chart, you can typically see a spike or a drop on day 3 because that is the first projected value based on the actual performance of the first 2 days. As time goes by, the lines get smoother, although sometimes someone has an extraordinarily good or bad day. Fun fact. If you have had a steady income since you were young, you can go offline for months without worrying too much about your declining remuneration. For example, if you take a break for 1 year after 10 years of hard work, that will likely decrease your earnings only by 10%, assuming that median performance in society is stable over the years. Finally, let me show you a connection to profit maximization in competitive markets. Those who have learned microeconomics are familiar with this chart on the left-hand side. Briefly, companies increase sales until their marginal profit is positive, meaning that selling one more unit generates more revenue than the extra cost. Therefore, profit is maximal, where the marginal profit is 0, red dotted line. In COSEEN, revenue can be replaced with ideas and cost with time. More thoughts increase collective intelligence until we do not get too tired to think efficiently. The same curves make a different sense from this perspective. For example, coming up with the first idea may be time-consuming. Later, we enjoy the effortless flow of thoughts, but after a time, we get tired and need to socialize, get outside, exercise, eat, sleep, and so on. This is true for a meeting, a work shift, a day, a year, and our whole life. As a result, to maximize collective intelligence, we should build a system that motivates people to share their thoughts, but take a break and recharge their batteries before they start to burn out. I hope that this simulation inspires some thoughts. Please help us by sharing your contribution to collective intelligence in the comments section. Thank you for your attention.